Okay, what we're doing is getting ready for the formula of a hydrate lab. And as we're getting ready for the formula of a hydrate lab, we're going through right now, how did we get the numbers and the information that we see within this first box? That's why the little blue arrows here. Okay, so would you please tell us, how do we get the mass of our evaporating dish?
Well, first you have to weigh it.
Weigh it and record it, right? Very simple. Okay. Now, what are we going to do to be able to get the mass of the dish and the hydrate?
Well, for this you have to weigh it again. And you have to subtract this one by this one, and you get this answer.
Okay. So, what do we do between this first line here, where we're doing the mass of the evaporating dish? What do we do to get to this line before we weigh it? What do we have to do?
Hydrate.
Shh.
I think you have to hydrate it.
No. It is hydrated.
Don't you cook it?
I'm sorry?
Don't set it on fire?
Nope. Okay, this is not the place where we're going to use the heat. See, you can't use the heat here because we're trying to get the mass as a hydrate along with the dish. We want the hydrate, we don't want the salt. Not here. So when I put the copper sulfate into the evaporating dish yesterday, the copper sulfate had to be in there if I was going to weigh it to be able to tell how much the dish and the salt is. I'm using the evaporating dish like a piece of filter paper. Okay? So that's what's going on here. We're using this as a piece of filter paper, and because of that, we have to have that second step in there, which gives us this 13.50 grams. Now, you said that you're getting this number here by doing what?
Subtracting the 15.35, 11.8.
Okay. Which number is going to be on top when you do that subtraction?
The 15.
15. Okay, good. All right. So far, so good. We got ourselves extra credit. Hurrah! Okay, my first question for Colleen is to take these guys, these labels, and put them next to the chemical formulas. Which one is the salt and which one is the hydrate? Just move them.
So,
Okay, the dry salt, the formula's down below. Down below. Yeah, Put it next to them. No, not there. No, don't move that, hon.
what?
Here.
Oh, this one or this
You want to move this guy. Put the label next to the formula. That one goes next to the formula for the dry salt. Come on, you can do it. There you go.
one?
Good, good. Okay, let me move that over for you just a little. Okay. No, don't double tap. Just tap it on the words.
Okay.
There you go. You have to press a little harder than that, that's all. Okay, now, she's got those properly identified. That's very, very important because you're going to use those terms throughout this lab. Salt and hydrate. Okay, so Colleen, tell everybody, what is the difference between the salt and its hydrate?
When it's hydrated, it's like when it has like water in it. And so when it's dry salt, it's without any water, so the water is evaporated.
Very good. Well said. That's perfect. Okay, how do we get the mass of the evaporating dish and the dry salt? And first of all, what do we have to do before we go for this number right here? Before we can get this number, what do we have to do after we get all of these numbers up here? You can't record these numbers until you do something. What is it you have to do?
Divide the mass and so.
No. What do you have to do experimentally?
You weigh them?
You've weighed them up here. Okay, the question was now, what do I have to do before I can take and get this number? I can't just do this and then do this. I have to do something in between. Read. What's between the boxes? And so what are we going to do?
So you weigh the evaporating dish.
You're not going to weigh the evaporating dish. You've done that already. The evaporating dish was weighed, and we recorded that here. Okay, then we added the hydrate, and we recorded the new mass here, using the evaporating dish like a piece of filter paper to set our stuff on. And when we subtracted these two, we got this number. Now, we can't weigh and get this number without doing something. What do we have to do? You got to do something in the lab before you can record it. Well, look, it tells you right there between the boxes. What do we have to do? Physically, what do we have to do? Heat. Heat. Okay. Heat. That gets rid of the water, right? Okay. Now I'll tell you tomorrow how long you're going to have to heat, but yes, heat. Okay. After we've heated it, do you think we should maybe let it cool down a little bit?
Yeah.
Okay. That's a good idea. We'll let it cool down a little bit, and then what are we going to do?
And then you weigh it.
You weigh it again. Okay. Have I taken anything out of the evaporating dish?
No.
Not physically,
No.
but what's gone now?
Water.
The water's gone. Good. Okay. Now that the water's gone, how do I get the mass of this dry salt? What do I have to do to calculate to get that?
Subtract the.
What from what? Getting this number?
Subtract the dry salt from this one.
No, you're getting the dry salt. What do you have to subtract from what to get the mass of the salt?
Second. From this one.
This one from...
This one.
No, forget about this. This is crossed out.
Oh.
Okay, this is like it's not there. Okay? Okay, look and see what you have here. Read this. What is this?
The evaporating dish and dry salt together.
Okay, if you have the evaporating dish and the dry salt both, what could you subtract from here to get this number?
Oh, the evaporating dish.
There you go. Okay, you just have to read it so that you know what you're doing. Okay. So here's our dry salt. All right? Not quite there, but you learned something, I hope. Yes? Okay. Alexa, you're on. Tell me about this second part.
Or
Come on up. First of all, how are we going to get this molar mass?
get the molar mass of all of them and add them together.
Ah, okay. So, are you going to be doing the dry salt, or are you going to be doing the hydrate? Very good. Did you all hear that? You should be taking notes on this, folks. Write it in your journal if you want. You can write it on the back of the paper that you picked up on the way in that has your practice problems on for tonight. Okay? This is something you want to understand. Okay, molar mass. Will the molar mass tomorrow be any different than the molar mass today?
No.
Well, we're going to be using
We're going to be using it.
then.
Very good. It can't change because the periodic chart has the masses on it, and they're no different from one day to the next. So when you get the molar mass, you have the molar mass Yesterday, today, and forever. Okay, so, good. We got our molar mass. Now, we've had how many magnesiums? And sulfurs? And oxygens? 4. Excellent. Okay, so that's how we got this. 1 times the molar mass of magnesium, 1 times the molar mass of sulfur, 4 times the molar mass of oxygen, and we're them free! We got a number! Ta-da! Oh, you're so excited. Yes. Okay, so how do we get the moles of the dry salt now that we have the mass and the molar mass?
Divide the mass of the dry salt by the molar mass of the dry salt.
Did you all hear that? The mass of the dry salt divided by the molar mass. That's going to give us the moles of dry salt. Okay, last thing coming up. So far, so... Okay, Edgar, how are we going to get the mass of water?
We have to divide.
Divide? What are you dividing?
Also water to molar mass water.
I'm asking you, how do you get this number?
We have to subtract
Subtract what from what?
mass hydrate, subtract the mass dry salt.
Okay, where do you get those numbers? Where did you calculate those numbers?
Oh yeah.
First of all, where's the mass of the hydrate? Which box, 1 or 2?
2.
Mass of the hydrate. All you gotta do is read the labels, man. It's all there.
Oh, it's first one.
Okay, first box. Where's the mass of the dry salt?
Dry salt is 6.
Second box. Okay, so that's where we're gonna get that information. All right, so we subtract those two. You got me doing a divide. Okay, we subtract those two and we get this number. It's just that simple. How do we get the molar mass of water?
We have to divide mass of water to molar
No,
mass.
how do we get the molar mass of water? Where did this 18 come from?
Oh,
Keep going.
divide the mass of water to mass of water.
How do we get the molar mass? Where does the molar mass come from? It's on the wall. What do you do to get the molar mass? Okay, go David.
The molar mass of water comes from the periodic table. It always stays the same.
Very good. And so how many hydrogens are in water?
2,
Okay, so we use that 2 to multiply what?
1, 0.
I'm sorry? Oh, yeah. Okay, good. And the water has how many oxygens in it? 1. And that's multiplied by... Very good. You got it in your head already. Excellent. Okay, and when we added those up, we got the 18, that is. Okay, so that's all good. And now we want to go down here. And where do we get the moles of water from?
You divide the mass of water with the molar mass of water.
Very good. Okay, just just like it says right here. Okay, it gives you the hint, mass of water divided by the molar mass of water, and that gives you the 0.0771. And now we have the moles of water. So the next step is going to be down here, and I'm going to give you 3 minutes for that. Somehow we only got here in one class, so I'm going to do this one on my own. And when you pick up your moles from one of the last sections here, the moles of the water over the moles of dry salt, that's going to give you a number. So we got our moles back over here. Okay, we got the moles of dry salt here, and we got the moles of, where's the moles of water? And we got the moles of water back on this screen. So once we have those two numbers, it's pretty easy, because we divide both the moles of water and the moles of the dry salt by the moles of the dry salt. And so that's essentially what happens here. So moles of water divided by moles of dry salt is how it works out technically. And we wind up with the moles of water over the moles of the dry salt to get a 4-to-1 relationship. Now we look at that 0.4 and we have to round that, because this number has to be an even number so that we have an even number of molecules ratio. And so that number is carried down to here. So the 4.4 is rounded to 1, and this 1 over here is representing the moles of the dry salt. So the water is 4 and the dry salt is 1. And that's how it works out. Remember that these numbers have nothing to do with reality. They're just numbers that we pulled out of a hat, and we started to do the calculations based on what we had. I just put in a number here and here and here. Okay, the places where you see X's, that's where I put in numbers, and then from there everything else is calculations. And the actual sheet where you're going to do all of these calculations looks just like the practice problems that you got in class to work on the night before the lab. And so again, I've shown you where the actual numbers are that you're going to get as masses when you work with your scales in class. And that's it, folks. Hopefully that'll get you good and ready for the lab. Thank you for watching. Just as a really short add-on, this is today's homework page, and the document that we were working on during class is right here. And if you wanted to get the handout that I gave in class today, that's right here. And that gives you a layout that is almost identical to the actual lab sheet itself, which you go Learning Center, Labs, and then go to Chapter 11. And right down here, you could have the PDF version or the HTML version. I'll do the PDF, and there's the actual lab sheet with all the directions that you're going to need. So, there you have it. Thanks for watching.